This is the View Pre-Calculus class. We're doing topic 6, which is more work with the unit circle, specifically figuring out how to find angles when we're given the value of a trig function. So we're picking up with example 2. So remember the relationship. The first thing you have to do is figure out the trig function you're given. How is that related to the unit circle? So tangent is the y on the unit circle on top of the x on the unit circle. And we're saying that equals 0. Well, if you multiply the x in the unit circle over, what you're going to get is that the y on the unit circle is 0. That's what you're looking for. So the only places that happens are here and here, right? So this is the point 1 comma 0, and this is the point negative 1 comma 0. And this is at 0 radians and pi radians, and then also again at 2 pi radians. So my answer is going to be 0, pi, and 2 pi. Just as a reminder, if this 2 pi had had a parenthesis after it instead of a bracket, I would have only done 0 and pi, but because it says include both ends, I include both ends. Now let's step it up a little in 2b where things get a little more difficult. So I know that the tangent on the unit circle is the y on top of the x, right? But, so that's actually, so y on the unit circle on top of the x in the unit circle, but that's actually not the trickier part here. The trickier part here is to look at this number and realize that there are no 3's in the unit circle. There are root 3's, but no 3's. So my brain says, wait a second, this must be the rationalized version of a negative 1 over root 3, right? Because that's what happens when you rationalize something. If you times by root 3 over root 3, you would get this, but we want the unrationalized version. And then my brain takes one step farther and says, wait a second, there aren't just root 3's in the unit circle. Any root 3 in the unit circle is over 2. So what if I were to take this expression and instead times it by a 1/2 over 1/2, because again, my goal here is to make it look like something on the unit circle. Well, what I'd get is that I have a negative, and we'll talk about why I put it in the middle in a sec, with a 1/2 on top and a root 3 over 2 on the bottom. So here's the information that I can get from this. Number 1, I want the y's to be halves. Number 2, I want the x's to be root 3 over 2's, which makes sense because those are at the same point. And then the third piece of information, which is important, is I need them to have opposite signs. Because remember that when you have a negative on a fraction, you don't actually know if the negative is on the top or the bottom. You just know that it means the top and bottom have opposite signs. So now I'm looking for places where the y on the unit circle is a 1/2, the x on the unit circle is a root 3 over 2, and they have opposite signs. Well, from my Algebra 1 knowledge, I know that the quadrants where signs are opposite are quadrants 2 and quadrants 4. So I want this guy right here where the y is, so this is the point where the x is a negative root 3 over 2 and the y is a positive 1/2. And I want this guy where the x is a positive root 3 over 2 and the y is a negative 1/2. So see how my y's are 1/2, my x's are root 3 over 2, and my signs are opposite. So my answer here is going to be this angle, which is 5 pi over 6, and this angle, which is an 11 pi over 6. So again, there's a little bit of a mental leap there. Now, having done 2b, I think you're going to find that 2c is not awful, right? So in 2c, instead of tangent, we have cotangent. So that's going to be the x on the unit circle on top of the y on the unit circle. And we know it's equal to a root 3, but you're better off if you write it as a root 3 over 1, because we know it's going to be a fraction of something over something. If you make that same mental leap and say, wait a second, there aren't root 3's on the unit circle, there are only root 3's over 2, you could times the top and bottom both by a 1/2, and you'd get that you're looking for an x value that is a root 3 over 2. You're looking for a y value that is a 1/2, and because this is a positive, they have to have the same sign. So it's a very similar problem. I'm still looking for actually the same points where the y's are a 1/2 and the x's are root 3 over 2's, but in this case, I want them to have the same signs, which puts me squarely in quadrants 1 and 3. Because this is the point root 3 over 2 comma 1/2, and this is the point negative root 3 over 2 comma negative 1/2. So my answer is pi over 6 and 7 pi over 6. All right, we're going to finish out the last 3, which are to D, E, and F. So I'm going to erase and make some space. So we need a 2D, 2E, and 2F. And then we'll have some practice problems. All right, so 2D is going to be when the cotangent of theta is a 1. 2E is going to be when cosecant of theta is a negative root 2. And 2f is going to be when the secant of theta is a 2. Okay, so I'm going to argue that the hardest ones we did were actually 2b and 2c because they required a lot more of a mental leap. So let's start with 2d. Cotangent is the x on the unit circle on top of the y on the unit circle, and it's supposed to equal 1. If you multiply your y over, you're going to get the x on the unit circle is the same as the y on the unit circle, literally the exact same point. Well, the only places on the unit circle where the x and y have the same coordinates are the pi over 4s. So what we're looking for is the same number and literally the same sign because there's no negative sign here. So I'm looking for the pi over 4s in quadrants 1 and 3. So this is pi over 4 because it's root 2 over 2 comma root 2 over 2, right? And this 5 pi over 4, well, the point here is a negative root 2 over 2 and another negative root 2 over 2. So my answer is going to be pi over 4 and 5 pi over 4. All right, 2e. Cosecant of theta is negative root 2. There's a couple different ways to think about this. Probably the easiest way is to realize that cosecant is 1 over the y value on the unit circle, right? If you clean this up by multiplying the y over and dividing, you get a 1 over a negative root 2 equals your y on the unit circle. If you rationalize this, you get negative root 2 over 2. So you're looking for where on the unit circle your y values are in negative root 2 over 2. Well, I know they're at the pi over 4s because that's where the root 2 over 2s are, and if y's are negative, I must be below the x-axis. So I end up getting the answer that theta is 5 pi over 4, which is this guy, and 7 pi over 4. Again, as you get better at doing this, you don't look at the circle. I haven't looked at it once, and I'm not saying that to brag. I'm saying that because it's knowledge you want to have accessible, but it's okay if it doesn't feel accessible when you're first learning. That's completely natural. All right, last one, 2f. The secant is 1 over the cosine, or it's the flipped version of the x on the unit circle. So you can either multiply the x over and divide the 2, or you can just recognize that you're flipping this value. That's fine too. But you're going to get that 1/2 is the x on the unit circle. Well, the 1/2 as x values happen at the pi over 3s, and if I want them to be positive, I need to be to the right of the y-axis. So my answer is going to be pi over 3 and 5 pi over 3. And again, I got a little bit lazy and stopped writing the points here. Most of the time, if I'm taking a test myself, even when I'm just doing it for my key or my own benefit so that I make sure I know what I'm doing, I just draw these little diagrams instead of listing the actual point values. All right, so now you're going to work on some practice problems with this. I think there are 12 of them, and that's the plan.